Okay, this is a short video on hints to solve problem number 2 of mixture compositions assignment that I gave you all yesterday. Take a look at it. Let me share the screen to see what we are talking about. This is problem number 2, right? And those of you who don't know what problem number 1 was, and here is a refresher on mixture compositions. This is what we did. And if you may remember, use the following formulae to answer problems 1 and 2. And so let me bring this on this side so it's easier for me to talk about. There you go. All right. So this is a cheat sheet, formula sheet relating concentration, mass fraction, mass percent, mole percent to various parameters. Take a look at it. If you are not familiar with it, you should be. The formula, the two sets of formula below. One set is for mass flow rate, the other was for molar flow rate, relating to various parameters. And so this would have helped you in your first assignment, which is here, an aqueous solution of phosphoric acid. So we did this. I have uploaded a video yesterday about how to tackle this problem using this set of equations. Take a look at it. And then now let's go to problem number 2, right? I mean, this the problem number 2 is this. Let me just put this up clearly. So yeah, let's make it like that. All right. So 2 organic vapors enter a separation column. One is anisole, the other is phenol. Total mass flow rate of the stream is 10,000 pound mass per hour. Mass percent of anisole in the stream is 40%. Determine the following: mass flow rate of anisole, mass flow rate of phenol, molar flow rate of phenol, the total molar flow rate of the stream, and the mole fraction of anisole. Here is the formula for anisole. Here's the formula for phenol, and you will need this to calculate the molecular weight or formula weight. Okay, so let's take a look at how do we go about this. Okay, question number 1 is what? Hints. Okay, this is hints only. Okay, you have to calculate it. This is the hints. So A, mass flow rate of anisole. Let's put this up here. Mass flow rate of anisole is, how do you represent that? Mass flow rate of anisole, right? Is what? Can you calculate this from what's given? Well, let's see what's given. What is given here, right? 1. Let's see. The total mass flow rate of the stream is 10,000 pound mass per hour. So total flow rate will be m total, right? So rate, so that's a dot on the head there, is what? 10,000 liters per hour, correct? No, pound mass. Liters would make it volumetric flow rate. So that's that. So what second thing is given is what? The mass percent of anisole is 40%. So what is mass percent? See that? Mass percent is 100 times X. What is X? X is mass fraction, right? So if mass percent is given, that means mass fraction can be calculated, right? So 100% XA, right, is mass fraction, right? Mass fraction. So for anisole, it's 40%. So X anisole is what? 40 divided by 100, that is 0.4, right? So X anisole is 0.4. That is given. Remember, it should all add up to 1, just as 40%, 100, everything should add up to 100%. So everything should add up to 1. Therefore, you know by inference, since there are only 2 compounds there, X-phenetol is what? What? 0.6, right? Because they should add up to 1.0. So keep this in mind, okay? This is an inference. I'm giving you hints, okay? So now how do you calculate the mass flow rate of anisole? You got to look back at the equations and see in this set of equations for mass flow rate, is there any equation that you can use, right? I mean, anything that you can immediately, you can immediately use. Given so mass flow rate is a lot of things. Well, number 1 fits, right? Mass flow rate of, say, anisole is the mass fraction of anisole times the mass flow rate of the mixture. So if you go back to this, we make it smaller. So X is given, so X total, right? So M total is given, here it is. X is 0.4, you got it, right? So let's go to B. Mass flow rate of phenetol. Mass flow rate of. So you can simply say that's also X phenetol times mass flow rate of the total, right? But you say, well, X, the mass fraction of phenetol is not given because only the mass fraction X of anisole is given. But you know by inference that the mass fraction of phenetol can be deduced, right? So you got that. These are just hints. So C, molar flow rate, right, of phenetol. So how's that? So you go back to the charts on now this set, molar flow rate, right? It says mass flow rate divided by molecular weight, or fraction times mixture by molecular. You can use quite a bit, right? Which one would you like to use, right? Well, mass fraction, right? Mass flow rate, sorry, of phenetol, right? Divided by, right? This makes sense, correct? The very first one. Because you already calculated the numerator in B. You got this, right? The molecular weight can be calculated using the formula given here, phenetol, right? And calculate the formula weight for that. What's D? The total molar flow rate of the stream. So the molecule, okay, let's total is what? Is equal to flow rate of anisole plus flow rate of phenetol, right? You got the phenetol here, right? So what's the molar flow rate of anisole? Exactly the same thing, right? Molar flow rate of anisole equals mass flow rate of anisole divided by molecular weight. You have the mass flow rate in A, right? You got that here. And molecular weight can be calculated by the formula of anisole. I'm sorry. So N total is what? Total molar flow rate is molar flow rate of anisole plus molar flow rate of phenetol. We have the molar flow rate of phenetol here. We already calculated in C. Anisole can similarly be calculated by dividing the mass flow rate of anisole divided by the molecular weight of anisole. And you have the mass flow rate of anisole in A, correct? So you got that. E, mole fraction of anisole, right? So mole fraction is what? What symbol is mole fraction? Is Y, right? Mole fraction is Y. Moles divided by moles of mixture, right? Or the molar flow rate of species A divided by the molar flow rate of the mixture, right? You have the molar flow rate total of the mixture. So Y, what, anisole? That's the mole fraction, is what? Mole fraction, molar flow rate of anisole divided by the total mixture. That is the total, correct? You got the total here in D. Right? This is solution to D. And there you have the anisole as, anisole is right here, right? You got that. Correct. So in essence, you have the whole thing. And so you have, these are just hints. Okay. So take a look at it, go over the video again if it's a little fast. And then that's why we have videos. You can pause and go slow, etc.